Hello, welcome to the Beginner's Guide to React. In this course, we'll take you from React Novice to Pro, covering everything from the very basics to advanced concepts, all in under an hour. Whether you're completely new to coding or looking to expand your skills, you're in the right place. Worried about complex coding? Don't be. We'll break down concepts and technical terms into bite-sized pieces, make it super easy for you to follow along. And here's the best part, you'll get hands-on experience by coding along with me. But before we dive into the course, let's talk a bit about React's history and why it's a game changer. React was created by Facebook's development team to enable rich and interactive web applications. It was open source in 2013 and quickly gained popularity thanks to its simplicity, flexibility, and efficiency. Fast forward to today, and React is used by giants like Facebook, Instagram, Netflix, and Airbnb, just to name a few. It's not just a library, it's become a thriving ecosystem. Now, what does all this mean for you? It means by learning React, you're gaining a skill that's in high demand, opening doors to exciting career opportunities and creative possibilities. So buckle up and get ready, because by the end of this 45-minute crash course, you'll have a solid understanding of React. If you're excited to begin this course, hit that subscribe button, smash the like button, and make sure to share the video with your fellow aspiring developers. Without further ado, let's jump right into our beginner's guide to React. Alright, let's get started on creating our first React project. But before we do that, we need to take care of a few dependencies. First, we need to install Node.js on our computer. So head to the nodejs.org website and download the latest version. We need version 16 as the minimum on our computer to follow along for this tutorial. Second, we need to choose our choice of text editor. I prefer and recommend VS Code simply because it's easy to use and it has a lot of inbuilt features that makes our life easy. So go ahead and install that on your computer as well. Once you have that installed, we're going to go ahead and open Visual Studio. In Visual Studio, we want to install a few extensions as well to make our project coding easy. First, we're going to go ahead and search for React, and you will find this extension, which is the ES7 Plus React Snippets. So go ahead and install that in VS Code. Next, we're going to search for an extension called Prettier. This extension will allow us to format our code as we work through it. So go ahead and install that. Next, we're going to go to Code and we're going to go to the settings of VS Code. Here, we're going to search for a few settings to set. So first one is Format on Save. So we're going to enable that. The next setting is Formatter. So here, we're going to choose Prettier as our choice of formatter. So once we've done that, we're ready to proceed with creating our first React project. Let's now proceed to create our first React project. To do that, what we can do is we can use the terminal that's built into VS Code. This is a really neat feature because it allows us to execute commands within VS Code. We don't have to switch between different windows. So to run the command, let's actually go back to our browser and we're going to look at the create-react-app.dev website. And the command that we need to run in our terminal or command prompt is npx create react app and whatever name that we want to give our project. In this instance, it would be my app. Now, I really recommend that we create a project with TypeScript. TypeScript is essentially an extension of JavaScript because it adds typing. That will really save us a lot of time because the compiler will check and find errors instead of us trying to do that during runtime and run into a lot of headaches. So I recommend that we do this. So let's copy the command. We're going to go to VS Code. We're going to go to the desktop and we're going to run the command. And we're going to keep the sample project name as my app. So once this is done, to open the project in VS Code, all we have to do is drag and drop into the editor. So some warnings, but we're going to accept. So this is essentially the project that is now open in VS Code. Now let's go ahead and actually run the project as it is created by the React library. So we're going to open the terminal again and we're going to go to the My App folder. So I'm just going to check that we are in that folder. We are. So what we're going to now run is a command called npm start. Now this will essentially start the development server and it will open a web browser with localhost. Don't worry about the port. It might be different on your machine. It doesn't really matter. And now we have our sample application running in the browser. Now, one of the neat things about React is when we make changes in our code, the browser, if the server is running, will reflect the changes right away. So as an example, let's head to the project and make some changes in the app.tsx file as it's written here. We'll get into the structure of the project in a few seconds in this video, so don't worry about that. Let's just go ahead and make the changes to see what happens. So we're going to go to the source folder. We're going to go to the app.tsx folder. Now, instead of this line, we're going to just type in hello world. And when we save this file, what we will see is the server has updated, and if we open the browser, we'll see the updated message. This is a really neat feature of React because it makes the development easier. We can see our changes right away and even catch errors right away. So that's it. That's how we create a React project. Let's now look at the structure of a React project. So when you have the project open in VS Code, you will notice 3 subfolders. The first one is Node Modules. This folder contains any reference and code of libraries that our code depends on. So any frameworks, any third-party source code that we need our project to run on. Now, we don't need to worry about this. We'll touch on this when we get into advanced React projects. So don't worry about it for now. The next project is Public. This is essentially a project that contains all static files, images, videos, anything that is static on our website. And in this case, the index.html page that is for our React project is in the public folder. Now, the next project is essentially where we will do all of our development. In this folder, we have all the React files. The project starts from React in the index.tsx file. And this is essentially a file that will have syntax that will be foreign to many of you. Don't worry about it for now. This syntax is essentially what we call JSX, or JavaScript XML for short, in React. We'll get through details of what the syntax is and how we work with this in our React project. So just hold on a few moments and we'll get into it in this video tutorial. Now, the good thing about React is that when we are developing code, the approach that React follows is essentially a component-based approach. What are components? Well, you can think of components as Lego blocks. So in React, we're essentially going to create Lego blocks. Now, Lego blocks would be, for example, it might be a component that is a button. It might be a component that displays a blurb of text, or it might be a component that displays a photo on a web page. Now, to make this a little bit clear, what I will do is I will show you a visual. So think of this visual as components that are laid on this web page. Now, in this case, we have four components, or Lego blocks in this case, 1, 2, 3, and 4. So think of 1 as maybe an image, 2 is maybe an image of a user, so we have created an avatar type of photo layout. 3rd is a blurb of text, and 4 is a button. What we do in React is essentially we develop these components individually. Then thereafter, when we have our web page, what we're trying to do is essentially lay out our Lego blocks or components across this web page so that we can create dynamic and interactive web applications. So it's basically like a Lego block type of approach where, in the end, it comes out looking nice and pretty, but it's made up of small components that are doing an individual task. Now, that is really the approach that React follows. And if we go back to the project, what we will see is in our sample project, there is a component called app.tsx. And this is just an example where it's just displaying an image and as well as it's just displaying a text, which is Learn React. So if I open the browser, you will see this is essentially one component which is displaying this entire section of the web page. Now, it's a good rule of thumb to keep components small and doing one thing so that you can keep them reusable and reuse them across your application. But it's really your preference on how complex a component you want to make. So that is really the crux of React in a nutshell. We previously mentioned that React uses JSX. So what is JSX? Well, it is short for JavaScript XML. And what it allows us to do is essentially mix JavaScript and XML together to create and describe functionality in our components. Now, if we look at the app component in our sample project, you will notice that what this component is doing is it's defining a function by its name and it's returning a value. The value in this case is a set of XML tags. Now in React, the HTML tags can be thought of as XML tags. We can use the HTML tags just as we would do in an HTML application, and React will take care of rendering them in the browser by using something called a transpiler. In React, transpiler essentially converts the code that we have written in JSX into separate JavaScript and separate HTML. So if we wanted to look at an example, let's head to babel.js. So we're going to head to that website, and in here what I've done is on the left side I've created a JSX tag, which is a header that has a message of hello world. Now this is JSX. On the right side is what we see is what the browser sees. Now the browser will actually see a pure JavaScript declaration. So in the browser, this React.createElement JavaScript functionality will be invoked to create a literal HTML tag with the message hello world. And that is really the beauty of React. It will essentially take our JSX, which is a mix of JavaScript and XML, and it will do its work behind the scenes to convert it into HTML and JavaScript so that the browser is able to understand it. Now in React, there are actually two ways to create a component. We have a function-based component and we have class-based components. Both of them are essentially trying to do the same thing. The nature of how we write our code is just going to be different. Now, most developers actually choose to use function-based components because they're easier to write and they're more concise. We might still see class-based components in legacy code, but we'll touch on that in a separate video. In the function-based component, essentially, if we look at it, it's as simple as we have a function that is by the name of the component, and the function is tasked with returning XML. Now in React, there is a limitation that when we are returning a XML from our function, we can only have one parent tag. So that is the limitation of React. But other than that, JSX is just mixing JavaScript and XML so that we can describe logic, we can describe layout, and in the end we can describe to the user whether we want them to read something or do something in the web application. And that's pretty much it. That is JSX. Proceed now to create our own custom component. So to do that, what we will do is in our source folder, we're actually going to create a subfolder, and we're going to call this components. This is a convention that's followed by most developers to create their custom components within this subfolder. Now we're going to create a new file, and we're going to give it a name of user greeting, and that is the name of our new custom component. Now, because in VS Code we previously installed the ES7 React snippets extension, what we can do is in our user greeting component to define the template code, the common repetitive code that is available and used in functional components. What we can do is we can type in RFCE, select that, and you will see the code is auto-populated. That is something that we can use to accelerate our development. Now in this user greeting component, right now it's just returning a div tag, which is user greeting. We're actually going to change this and instead return a h1, which is the header tag, and we're just going to say hello John. We're going to go ahead and save this. And now what we're going to do is we're going to navigate to our app component, and instead of returning the predefined template code, we actually want our application to display our custom component. Now in React, our components get converted to equivalent XML tags. So to use our components within other components, we can use them just as we would use an HTML tag. So we would just essentially add a tag, which is user greeting. Now VS Code actually did an import of our custom component, so that's taken care of. And now our app component is now a parent for the user greeting custom component. Now if we were to save this and head to our browser, we will see hello John is displayed in the browser. And that is it. That's how we create a simple functional component. Next, we'll look at how do we add logic and add some functionality to this basic functional component. When we are creating custom components, it's rarely ever going to be the case that we are simply displaying data without any logic. What will likely happen is when we're creating custom components, we will have our data within variables and we will need to perform some operations or logic to manipulate the data and then display to the user. So how do we do that? Well, in React, because functional components or components in general are based on JSX, what we can do is we can use the power of JavaScript. So let's take a look. In our user greeting component right now, we have a function that's returning an XML tag, which is a header that says hello John. Now, what if we want to generalize this custom component to instead display a name of a user that's in a variable? So to do that, we can simply define a variable as we would do in JavaScript, and let's call that user's first name, and we're going to give it a value of Jane. Now in React, we can actually mix XML and JavaScript together through the use of expressions. Expressions allow us to embed JavaScript expressions into the XML, and what that means is the expression is just an evaluation that returns a value. The expression must always return a value because the XML is going to expect some sort of data to be available to be rendered in the browser. Now the value that the expression evaluates to can be simple values such as a string or an integer, or it might even be another custom component. So in that case, the expression might return the XML tag of that custom component, and that will be totally fine. But in this example, we are going to simply evaluate the variable, which is user first name. Now, when React encounters it, it's going to evaluate the variable and it'll know it's Jane, so that the browser, when it encounters it will have the value and it'll have a string that says hello Jane. Now, if I head to the browser, this is demonstrated right now. So that's pretty much it. Now we can take a step further and we can add some further logic just to demonstrate that there is no limitation in terms of the JavaScript code that we can write in React. The only limitation is the custom component. If it's named user greeting, it must have a function called user greeting, and then that must return an XML tag that tells React how to render that custom component. Other than that, we can write here any JavaScript code, and we can additionally define functions. So here we can say function ABC, and this could be doing anything we want, and we can invoke this function from essentially invoke it here as if we would invoke any other JavaScript code. But we're not going to do that in this example of the video tutorial. Instead, what we will do is in this functional component that we have, we're going to actually instead add some logic so that it's a little bit smarter and it doesn't say just hello. Instead, it will say good morning, good afternoon, or good evening, depending on the hour of the day. So how do we do that? Well, for people familiar with JavaScript, again, this will be very easy. We will just write some JavaScript code. So here we will create a variable which captures today's date. From that, we're going to get the hour of the day, get hours. We're going to define a variable that we will assign a value to for the greeting. And now we're just going to write if else statements. So if the hour is less than 12 p.m., we want to greet the user and say, for example, morning. So good morning. If the hour of the day is more than 12 p.m. but less than 5 p.m., then we want to greet them and say it is afternoon. And if the hour is less than midnight, then we want to greet the user and say evening. Now, instead of saying hello, what we can do is we can create a label that says good, and then we will evaluate greeting. So then that way the code will evaluate good morning, good afternoon, good evening, depending on the hour of the day. Now, if we were to save this, we will see the code is formatted because we're using prettier. Now, if we head to the browser, we will see it's good morning Jane because currently it is the morning time. So that's how we can add logic to our custom components in React. Let's now discuss how to add styles to our custom components. Now, one of the advantages of React is that because we're using JSX and we are creating XML tags, where HTML tags are also converted to XML tags that we can use, we can actually incorporate style sheets using the same method as we would do in a HTML-based web application. So what we can do is we can create inline CSS, we can create a CSS file, we can use CSS modules, and there's a few other methods. We'll get into some of the advanced CSS methods in a separate video, but let's discuss how we add styles in a simple example where we're going to essentially create a CSS file. So in our source folder, we're going to navigate to that folder and create a new subfolder for style sheets. So let's go ahead and do that. In this folder, we're going to create a new file, and we're going to give it a file name of user greeting styles.css. So this is a style sheet specific to our custom functional component. In here, we're going to create just a primary CSS class, and we're going to create a color which is orange. Now, to incorporate this CSS into our custom components, again, it's simple as what we would do in a JavaScript or a HTML application. We're first going to import the style sheet. So we're going to you look at the folder. So dot is for the current folder, dot is for the parent folder, and navigate to the style sheets and import the user greeting styles.css. Now that we have done that, we can now navigate to our JSX, and here now if we look at it from a HTML equivalence, we would use class. So to avoid conflicts in React, React actually uses class name in JSX to avoid any naming conflicts. So in class name, if we were to add our primary CSS class, which we defined in the user greeting styles.css file, that would allow us to style the header that we have for greeting of the user. So let's save this, and if we head to the browser, we will see the text has turned to orange. So that's the simplest way to incorporate styles in React. Simply create a CSS file and use the CSS classes as you would do in an HTML based application where you have tags, paragraphs, divs, etc. So same concept here, and that's how we can incorporate styles into our functional components in React. Let's now get into some of the advanced topics in React. As you may have noticed, in our sample functional component, we're actually only returning one tag. Now, it's going to be often the case that we need to have multiple tags nested in our functional component to create something that we want to display in our web application. So what can we do? Well, let's start by actually adding another tag in our return value of the functional component and see what happens. So here we're just going to create a paragraph tag, and we're going to call this is a test example of multiple tags. We're going to save this, and now if we head to the browser, we will notice there's an error, and that's because there's a limitation in React, which we touched on a little bit earlier in our video tutorial. But the limitation is essentially that our functional component can only return one parent tag in the return value, and that's what the error message is saying. adjacent JSX elements must be wrapped in an enclosing tag. So what can we do? Well, a crude solution and a simple solution would be to incorporate a parent div tag that would essentially be the parent of the child components. And if we did that and then head to the browser, we will notice the error is gone. But if I now look at the source code that the browser had, what we see here is there's actually a div tag that we added simply to get around the limitations in the React library. Now, that's not really a good solution because we're adding additional tags and it just complicates the code that the browser has to render. So what can we do? Well, React actually has a solution to this problem, and that's what React fragments are. React fragment, so let's use that, react.fragment. And React fragment is essentially a way for React to have a hierarchy of components without actually rendering anything in the browser. So what do we mean by that? So let's look at actually what happens when we use React fragment and what is actually available in the browser. What we will see is we're actually able to now have a child component with the header and the paragraph, but it doesn't have a div tag that is rendered and provided to the browser source code. So React fragment is just a way for us to add functionality to our components that allows us to return multiple child JSX tags. Now, there is another efficiency React provides, which is to make the code more concise. So instead of actually having react.fragment, we can actually just have a parent tag that is an empty tag. And if we just use that and now look at the browser, same thing, it's able to render because React behind the scenes will interpret the empty tag as a React fragment. And that's in a nutshell what React fragments are. They're just a functionality that allows us to have a functional component that's able to return multiple child tags in its return value. Whenever we are developing components, whether functional components or class-based components, we will need to handle events. Events are essentially interactions on our web application. For example, the user might do a button click, and in our web application, we should do something in response to that interaction or the event. So how do we do that? Well, it's actually not that different from what we would do in a JavaScript-based code. So as an example, let's just go ahead and create a simple button. The button will just be labeled as click me. Now, if I go to the browser, you will notice upon clicking, nothing happens. And that's because we have not defined what we want to do when the button is clicked. In React, it's not that different from JavaScript as I previously mentioned. So here we're just going to leverage the onClick property. This property is available on JSX tags, the HTML tags that we have, as well as custom components. So on click, I'm going to define an arrow function, and this arrow function is just going to display a simple message on the console in the browser, which is button was clicked. Now, if I save this and head to the browser, and I open the developer tools in the browser, head to the console. Now, when I click on the button, we will see that the button was clicked. Now, that's really the simplest form of handling a button click. I'm going to clear the console and I'm going to go back to my code. Now, let's say we want to determine what event actually occurred. In JavaScript, when we are handling events, there is a parameter that is passed in, which is E, or some developers choose to use event. So now if I look at the code in React, we can actually use the similar parameter, and if I were to print that on the console, now let's look at what that event actually is. Now I'm going to click on the button and we will see the object is actually a synthetic base event. This is an abstraction that the React library provides because the event that the browser has is different depending on what browser you're using. So to make our lives simple as developers, React team has abstracted away and defined their own event, which is synthetic base event. If I look at details of this object, it will provide the similar details that we would get in JavaScript, which is, for example, the location of the mouse click and some other properties that we might be interested in to determine how best to respond to the event. Now, let's clear the console and head back to the code. Looking at the code right now, the way we have defined the event handling mechanism, this is inline function. Now the inline function is good when we have simple event responses that we need to define in our application code. But oftentimes the code that we will have run when the event occurs is going to be complex and it's going to span multiple lines. In that case, just as we would do in a JavaScript based application, we should define a function that encapsulates the functionality of the button click, is in this instance as an example. So to do that, we would define a function just as we would do in JavaScript. By convention, we'll start the function name with handle. This is just simply convention developers use so they know this is an event handling function. And what event are we handling? This is the click event. Now we're going to proceed and define the arrow function, which we had previously defined inline. And again, we're going to keep it simple and we're just going to print the event on the console. Now, if you look at the error, which VS Code is actually giving this error because we're using TypeScript. We did not get the error inline because the TypeScript compiler is able to infer that the event is a React.mouse event, which we can determine by hovering over the variable. Now, the reason the TypeScript compiler is not able to infer that this is the similar mouse event is because the compiler does not actually know where this function is going to be used in our code. Whereas when we have the function inline, the compiler is able to determine by inference that this is going to be a React mouse event. So to solve the type safety in TypeScript, what we can do is we can import the mouse event from the React library and add the type to the function definition that we had defined. Now I'm going to replace the onClick inline function and refer to the function that we just defined. Now here we want to provide the reference to the function and we don't want to call the function. If we look at the way React works, React expects a function reference because it wants to know the function that it should call when the interaction or the event occurs at runtime. So for that reason, we always pass a reference to the function and not call the function. So if I were to save this and head to the browser, the console is cleared. Now if I click on the button again, we see the event is printed again. And that's in its simplest form how we can handle events in React. So we can define inline functions, or we can abstract and separate the functionality into functions within the functional component. And that's it in a nutshell. Now let's discuss how we can pass data between the components. In React, whenever we are developing custom components, we will usually require some sort of data to be passed in. That is usually a good practice to allow the component to be reusable in our application. So let's explore how we can do that. In React, there is a capability which is enabled through props, or short for properties. Now, as an example, when we previously looked at event handling, we looked at a property called onClick. This is essentially a way for us to pass data to the button component. But we can expand on this topic further and define inputs to our own custom functional components that allows the parent component that is using our component to pass data to us. So let's do an example to explore this feature. So in our component user greeting, right now we have hard-coded the user's first name. Now we don't want to actually do that. We want the parent component to pass in the user's first name that should be displayed by the user greeting component. So how do we do that? Well, what we can do is first we need to define an interface for an object that will define the data fields our user greeting component is able to accept. So let's go ahead. So let's define an interface called props. Now we can define the interface name as props, or we can define it as user greeting props, essentially prefixing the name of the component. It's really your preference what you choose to do. Some developers will choose this naming convention, or you can do just props. Let's just use the short form and continue. In the interface, we're going to define the data element that we require to be passed in as a property to user greeting. So we need the user's first name. And now, because we are using TypeScript, we need to define the type of data element user first name is. In this case, it's a string. Now, to use this interface in the functional component, we need to add a data element here, which is props, which is going to define the object of the properties that we need to be passed in as data input. So this is going to be props. Now let's get rid of the hard-coded variable that we previously had, and we will see an error in VS Code because it does not have user first name anymore. Instead, what we need to do is we need to use props.user first name because we have encapsulated the first name as a property in the properties object that we will require in React to be passed into user greeting component. So let's save that. And now if we look at the parent component, we will see an error. And the error is that the user first name property is missing. So let's add that in. So user first name. In this case, we're going to define the user's first name, and let's say this is Jeff. So let's go ahead, save. And now if we head to the browser, we will see it says good morning Jeff. So what we have done is enabled our user greeting component to receive the user's first name as an input. Now, one of the efficiencies that we can leverage through JavaScript ES6 is rather than having props as the data element, we can actually use data destructuring to simplify our code. So what we can do is we can define through destructuring the element, so user first name. And when we use the element, we can use it as if it were a local variable in our functional component. So we don't need to use props dot. Now, if I just remove props dot and save, head to the browser, everything still works, and we can now keep on going and add additional data elements if we need to. So that is in a nutshell how we can pass data to a functional component via props. When we are working with props or properties for components in React, we can provide as input data as well as functions, and that allows us to factor out functionality that we need to be executed in response to events. So as an example, in our custom functional component, we currently have a button component that we are using, and in this button component there is a property called onClick. Now, as you may have noticed, instead of providing data to this property, we actually provided a function reference, and what that allowed us to do was tell the button component that we need this function to be invoked in response to the click event. Now, if we expand on this further, we can actually build this functionality in our own custom functional components. So we can provide essentially a way for us to accept as input functions that will be invoked when certain events happen. So let's do an example. So in our interface props, we will add a data element, which is handle button on click. This is going to be of type function. So this is going to be of type function, which accepts as input an event, which is a mouse event. And the function will not return any value, so it will return void. We need the function to be invoked. We don't need any data to be provided back to the user greeting component once the function is executed. Now, if we look at the data destructuring, we need to add this additional data element, and in our button tag, we need to invoke the function which is provided as a prop. So we will use an arrow function and invoke the button on click. Now there is an error because in our interface we define that this prop accepts as input an event. So let's add that in. Okay, now the local function that we had previously defined, we will factor this out from the user greeting component and instead define that function behavior in the parent component. Now there is an error that we will see, which is that the property handle button on click is not used So we need to use that property. So handle button on click, and in that we will provide the reference to our function that we want invoked. Now the error will occur because we have not defined the mouse event in the parent component, and that's because we have not imported it from React. So let's proceed and import that from React. I'm just going to copy this from the user grid component to save some time. Now that is done, we will see the error is gone. Now, just to summarize, we defined as a input in the props function that we needed to be provided from the parent component, and we are invoking that function in response to a click event. This function is defined in the parent component as handle click. So now if I head back to the browser and click the button, we will see it works as expected, which is providing a print on the console. So that is in a nutshell how we can provide functions as inputs to props or properties in React. When we are developing components, whether functional components or class-based components, we're going to need to maintain state. Now, some of you might be wondering, well, what is state? Well, you can think of state as a way to maintain information in our component that is changed in response to user behavior. For example, we might have a carousel of images, and in that carousel component, we need to have information about the currently displayed image, so the index of the current image that's being displayed, and that should change in response to a user behavior. So if the user were to click the next or the previous button, the component, which is the carousel, should update the image and maintain information on the newly selected index on the basis of the user action. So it's, in a short form, state is a way for components to maintain information that allows them to display the right information at the right time. Now, you might be wondering, why can we not use JavaScript variables? Why do we need state? Well, let's take a look at an example to see why we need to add state instead of JavaScript local variables. So in our project, we're going to go to the components folder. We're going to add a new component. We're going to call this component counter. We're going to create the template code using RFC shortcode. And in the counter, we're going to have two things. We're going to have a counter of values, and we're going to have a button that increments the counter. In a real-world application, this component might be a component that displays followers for a user, the number of followers the current user has, and when the follow button is clicked for that user, we need to increment the follower count. So in our counter component, let's add some basic functionality. We're going to add a JavaScript local variable, which is going to be initialized to 0. And in the JSX, we need to add two UI elements. The first one is a label, which displays the current counter value is, and we're going to use the expression, and we're going to have a button. The button will be increment counter. Now we need to define a function that will be invoked in response to a click event of the button. So let's go ahead and define that. So handle click, and it's going to be using an arrow function. The function is going to do two things. It's going to increment the counter, and it's going to display on the console the current value of the counter variable. So counter. Now in the button tag, we need to use the onClick prop and pass in the reference to our event handling function. So what we need to do now is, in our parent component, we need to use our newly created custom component, which is counter. So we've added the JSX tag, and we need to do an import as well, so that the source code can be linked to the use of the tag. So now if we go to the browser and we clear the console and look at the web page, we'll see the current counter value is 0. Now if I were to click the button, the counter value, you will see it's getting triggered, and what that means is the locally scoped variable is getting updated, and hence we're seeing the updated values in the console. but the web browser is not getting updated. It's not getting a refresh of the counter component. For that reason, it continues to show the current counter value is 0. And that is the limitation of using JavaScript local variables. There is no way for React to know that it should pay attention to a particular variable and that it should trigger an update of the component when that information in that variable changes. So state is a way for us to maintain information that impacts the behavior of the component. So in our interactive web applications, we're often going to have components that have functionality that is getting triggered by a user action, and they need to display some new information on the browser. So how do we use a state in React? Well, to use the state in React, what we need to do is use the useState hook that the React library provides. Hooks are multiple functionalities, multiple capabilities in React that allow us to do different things. State is one of them, and we'll touch on some of the other functionalities and capabilities in our later video series tutorial. But when it comes to state, we need to use the hook, which is enabled by the useState function. Now, the useState function essentially accepts as input an initialization value, and this will return an array of two things. The first is the variable, and the second one is the updater function. So the return value essentially is the variable and the updater function. The updater function is what we need to use to update the variable that is represented by our use of the state. The updater function will tell React that it needs to trigger a re-render when the value of the variable is changed. So now if we leverage this functionality, what we need to do first is import the useState hook from the React library. And instead of using a locally scoped variable, we're gonna now use state. So we're gonna have an array which is gonna have as first parameter the variable. The next parameter is the updater function, which is gonna be update counter, and we're gonna now initialize the useState and set the initial value of 0. So that's in a nutshell how we can use state in React. Now, when it comes to triggering an update, what we had done previously was we had simply gone ahead and updated the value of the variable. Now, when we're using React, this is not the correct way, because this will not allow React to know that it needs to re-render the component in the browser. What we need to do instead is use the updater function. So let's go ahead and use that. In the updater function, we're going to essentially have a function which will take as input the current counter value and provide as output the updated value. So let's go ahead and clean up the code. Now, if I were to click save and then head to the browser, I will clear the console so we can see an update from the beginning. Now the browser is showing the current counter value 0. If I were to click the button, we will see that the browser is now getting updated. And that's in a nutshell how we can add state to our functional components in React. We will often run into a situation where we need to display different things depending on different conditions. And in React, we can do that using conditional rendering, which is based on using JavaScript in JSX. Now let's take a look at an example. In our project right now, we have a custom component that displays a list of menu items that a coffee shop provides to its customers. Now, as input right now, we have an array of string, and each string represents the name of the item that a coffee shop provides. Let's assume that we enhance the input data to be represented by an object, where each object has a data element that has a name and a variable or a condition that indicates whether the drink is a hot drink or a cold drink. This would be more representative of a real-world data input that you would get into a custom component. Now, to leverage this additional and enhanced data, let's also define a function that will take as input the data and return a list item. so that we can be smarter and we can as well factor our code as we progress through this example. So let's define a function which is getListItem, and this function we're going to define it as an arrow function. The first parameter is going to be a string, which is the name of the drink, and the second parameter is a condition, which is whether the drink is a hot drink or not. Now in the body of the function, we're actually just going to return a list item, and for the list item we're going to define the key prop as the name of the item, because we know in this example the names are unique and the name is what we display as the name in the list item. Now in the map method that we had previously used, we're actually just going to leverage our function. So we're going to call our function, which is getListItem, and provide as input the data elements from the object. Now we're going to save the code and we're going to now head to the browser, and in the browser we're going to clear the console, and if I refresh the page we will see the menu items for the coffee shop are rendered. Now suppose the coffee shop wanted to have a menu of only hot drinks. So let's say the menu is segregated. So in this case we only want to display hot menu drinks. So what we can do in our function, which is getListItem, is do a check, which is if the drink is a hot drink, we're actually going to return null, and otherwise it will continue to return the list item. Now if I go back to the browser, we will see that nothing is displayed, and that is because what we said was if the drink is hot, it returns null. But what we should have said is if the drink is not hot, then we return null. So if I go back to the browser, we will see the menu items are rendered. So this is how we can add, as an example, a conditional rendering. Now we can take this a step further. Suppose we did not want to only display hot menu items. Rather, we wanted to display each menu item but indicate whether the menu item is a hot drink or a cold drink in the same menu display. So how can we do that? So what we can say is if the drink is hot, we return a different list item, and if the drink is a cold, we return similarly a different one. Now what we can do is if the drink is hot, we are actually going to suffix the name with a fire, a character code, and if the drink is a cold drink, then we're going to suffix the name with a snowflake symbol or a character code. Now if I save this and head to the browser, we will see that everything is displayed as a fire symbol, and that is because everything right now is indicating that it's a hot drink. Now let's suppose we actually change the input data and we say the lattes are both cold. Now if I make that change, save, and head to the browser, we will see the menu is updated, and menu is showing whether the drink is a hot drink or a cold drink. So this is another way to do conditional rendering in React. Now it's very simple actually, because we're only using JavaScript syntax and if else conditional checks to essentially render JSX tags in our custom functional component. Now the way we've rendered this so far, it's a little bit messy, and what we can do instead is we can actually leverage the JavaScript ternary operator to make our code a little bit simpler. So what we can say is we want to return the list item, and instead of having this name plus the character code for fire or snowflake, we're going to say name plus, and we're going to do a check, which is hot, and if it is, then we will provide the fire character code, and if the drink is not hot, then we will display the snowflake character code, and we will get rid of the previous code that we had used using the if then else. So this is using the ternary conditional check. So now if I were to save this, head to the browser, we will see everything is still rendered, but the way we've written the code, it's a little more elegant and it's a little more concise, and this is what most developers will use. Now we can actually take this a step further by using another syntax that is enabled by JavaScript. So let's say in our example we only want to display again only the hot menu items. What we can do then is what we essentially use the AND operators in JavaScript. So what we will do is we will return is hot, and we will return the list item, which is going to capture the menu item. So we're just going to write the key prop, which is name, add the name in the list element, and we will return if it's hot, then we will return that. If it's not hot, then we will not. So now if I go back to the browser by saving, we will see only the hot menu items are displayed. Now why is that? The reason is because of the way JavaScript works. So in our console, which is a JavaScript editor, let's take a look at what JavaScript does behind the scenes. Suppose I have a condition which is true, and I use the operator ampersand and say 1. We will see it returns 1. But if I have false ampersand 1, it returns false. So it's basically a shortcut to the ternary operator, which a lot of developers use in React to simplify their code. And that's essentially the power of the ampersand. It's just another way to run a condition check using JavaScript in React. Now that is in a nutshell how we can enable conditional rendering. Now one last thing that we will do to demonstrate conditional rendering capability is we can as well assign JSX tag into variables. So we can say for example we can define a variable, let's say let JSX tag equal, and we can return or copy rather the element we had defined, and in return we return the JSX tag data element. Now this is just a way to assign JSX tags into variable if that helps to simplify our code, if the logic of our custom component gets complex. Now if I save and head to the browser, we will see it still works as expected. And that is in a nutshell how we can enable conditional rendering in React. Thank you for watching this course. If you found it helpful, please click on that subscribe button and hit the like button. As well, stay tuned for more videos to come. Thank you again.